Welcome back to RigPro Academy. Episode 4, Top Drive Failure. What went wrong? Electrical or mechanical? Let's find out. RigPro Academy, Episode 4. Real rig failure case study. Top drive stopped during connection, no torque, no rotation. Today, we're dissecting a real-world top drive shutdown. You'll learn the red flags, the diagnostics, and how to solve the problem like a pro. Imagine you're mid-drilling, and suddenly the top drive locks up. The rig comes to a halt, and everyone's asking, was it an electrical failure, a mechanical issue, or something worse? Top drive failure, what caused the shutdown? This was a real case from an offshore rig. A fully operational top drive system stopped cold, no warning. Moments after the top drive came to an unexpected halt, the drilling crew acted quickly. Communication was clear: secure the well, shut down power, and call in the ENI team. Here's what we found after digging deep. What are the suspect areas? Number 1, electrical. Electrical suspects: PLC communication loss, blown fuse or breaker, ground fault, faulty VFD. Number 2, mechanical. Mechanical suspects: gearbox jam, motor bearing failure, misaligned couplings, hydraulic lockout. Electrical versus mechanical, know the signs. Putting the pieces together: high torque drilling, possible momentary binding, worn coupling. All signs point to a combined electrical-mechanical issue, the kind of failure that doesn't leave just one fingerprint. They spotted a coupling misalignment, not catastrophic, but enough to add stress. Combined with high load torque, it might have caused the VFD to trip out of protection. Now it's time for a closer look inside the top drive. The mechanical team joins in. Brake system, secure. Gearbox, dry. No visible leaks, but something isn't adding up. Voltage input, stable. Frequency, nominal. The VFD seems healthy. Next step, check the load. Could something on the mechanical side have caused the surge? He cross-references the code. It's a motor over current trip. That could mean an actual motor problem, or something upstream or downstream dragging the load. The electrical engineer starts where it makes the most sense, the VFD panel. Was it a power drop? A VFD fault? Or maybe a sensor failure? He checks the display screen, blinking red, code F53. This is the investigation mindset, methodical, multidisciplinary, and always guided by the facts. This wasn't just a simple failure, it was a layered event, and it highlights exactly why electrical and mechanical teams must work hand in hand. The verdict? A combined fault. Mechanical stress triggered an electrical response. The crew compares notes, timeline, activity logs, motor data, mechanical condition. This might have increased torque resistance, enough to trigger an electrical protection trip. The brake system appears intact, no oil leaks, but the coupling shows signs of abnormal wear, minor misalignment. He tags in the mechanical inspector. Together, they open the top drive housing for a closer look. It's not just the VFD, something else caused the overload. He digs into the logs. Voltage input? Stable. Frequency? Within normal range. But the motor current spiked just seconds before the trip. First stop, the VFD room. The electrical engineer checks the drive interface. A red blinking fault code, F53, motor overcurrent trip. Immediately after the top drive halted, the rig's priority was safety. The well was secured, power was isolated, and the call went out to the troubleshooting team. These tips aren't extras, they're essentials, because when your top drive fails, your entire operation halts. Let's keep it turning, let's keep it safe. And never underestimate your maintenance schedule. Preventive maintenance isn't optional, it's essential. Build a system and follow it, no matter what. Training matters. Make sure your crew is always up to date on LOTO procedures and emergency shutdown protocols. A fast response can save lives and equipment. Don't overlook the digital layer. Backup VFD and PLC logic regularly. A power spike or glitch can wipe vital control settings. Mechanical failures often begin at the bolt. Torque check your fasteners, drivetrain connections, and motor mounts, especially after rig up and transport. Start with strong habits. Weekly electrical inspections. Don't just look, inspect for overheating, loose terminals, worn insulation, and moisture intrusion. These are early signs of system failure. Now that we've identified what went wrong, let's talk about prevention. Because on the rig, downtime isn't just expensive, it's dangerous. Ready to go deeper into top drive safety and performance? Download your free checklists and field tools today. And if you want the full guide, grab our new ebook, RigDrive, Mastering Top Drive Systems, From Power to Performance. Let's stop guessing and start leading, only at RigPro Academy, where safety meets skill. Field tip: keep a printed copy of your top drive emergency shutdown checklist in the driller's cabin. Laminate it, mark it, use it. When seconds matter, clarity saves lives. When a top drive stops working, it's never just one thing. It's the sum of small oversights, miscommunications, and missed warnings. In this case, a combination of thermal overload and a loose mechanical coupling triggered a chain reaction. But what if the inspection checklist had flagged it? What if the VFD had been monitored more closely? Every failure teaches us something. 1. Inspect before you expect. 2. Never skip that test run. 3. If it feels off, it probably is. And above all, remember, you're not just protecting equipment. You're protecting lives. Thank you for watching RigPro Academy. See you next time.